The objective within this lesson is to multiply 3 and 4-digit numbers by 1-digit numbers applying the standard algorithm. Here we're asked to solve 3 times 1,353 using partial products. Here I've set this up, 1,353, and I've written now times 5. So I rewrote it to look at 1,353. To solve using partial products, what we'll do is we'll look at each part of this number. If we looked at this first part here, the 3 is worth what? And that first 3 is worth 3 ones. And when we take 3 ones and we multiply by 5, what do we get? Right, we get 15 ones, which is also equal to what? 15. So we worked with this 3 here, except there's still some other numbers within this here. We have the 5 here, which is worth what? 5 what? Right, 5 tens. And we multiply 5 tens times 5, what do you get? Sure, you get 25 tens, and 25 tens is worth what? 250. So far, with this multiplication problem, I have 15, which was 3 times 5, and I also have 250, which was 5 times this 5, which was worth 50. How about this 3? It is worth 3 hundredths, and 3 hundredths times 5 is what? Well, 3 times 5 is 15, and then we have 15 hundredths. How do we write 15 hundredths? Did you say 1,500? Lastly, we have this 1, which is worth what? 1,000. And what are we multiplying by? 5. That will equal 5 thousandths. And how do we write 5 thousandths? 5, 0, 0, 0. So I have taken 1,353 and multiplied it by 5 with the 3 ones, the 5 tens, the 3 hundreds, and the 1,000. I have these partial products, 15, 250, 1,500, and 5,000. What do I do with those partial products? We will add them. In the ones place, we have 5 when we add all that together. In the tens place, we have a 1 and a 5, which is 6. In the hundreds place, we have a 5 and a 2, which is 7. And in the thousands place, 1 plus 5 is 6. So I have the number 6,765. So that 1,353 times 5, which is also equal to 3 times 1,353, does equal 6,765. Here's that same problem using the standard algorithm approach. We take 5 times the 3 ones, which is equal to 15. In the ones place, I'd record a 5, and I would regroup the 1 to the tens place. 5 times the next 5, and that's 5 tens, is 25 tens, plus 1 more is 26 tens. So I'll record a 6 and regroup the 2. Next, I have 5 times the 3 hundreds, which is 15 hundredths, plus 2 is 17 hundredths. Before I went the plus 2, that 15 hundredths, hey look, it's right here within that partial products. The plus 2 was right here, where it is I was multiplying 5 tens times the 5, and that's where my regroup came in. So I was at 17, so I will record a 7 and regroup a 1. Finally, I'm at that last little portion right here with the partial products in the standard algorithm. 5 times 1 is 5, plus 1 is 6. 6,765. So, the one I just placed in the box is the standard algorithm, and it does connect with the partial products approach. Here is a problem for you to try. Please pause the video. It says to use the standard algorithm to solve this here. You start with this 4 times the 6 ones. That gives you 24 ones, which you write as a 4 and regroup the 2. Next you have the 4 times the 3, or 4 times 3 tens, which is 12 tens, plus another 2 is 14 tens. And we are already in the tens place, so we record a 4 and regroup the 1. Finally, you have this here. We have 4 times the 2 hundreds, which is 8 hundreds, plus 1, which is 9 hundreds. So that 236 times 4 does equal 944 using that standard algorithm. Let me show that to you using a partial products approach. Here's 236 times 4. First step, 4 times 6. Hey, 24. 24 ones, which I write as 24. Next, 4 times this 3. That 3 is worth 3 tens. 4 times 3 tens is how many tens? Right, 12 tens, which we write as what? Right, 120. And then lastly, I have the 4 times the 2 hundreds. 4 times 2, 8. 8 what? Hundreds. How do I write that? It's an 800. What do I do with all those numbers? We add them. We have a 4 there, another 4, and a 9. Does it match? Yes. So I used a standard algorithm, and you did too, and then I just showed you a partial products approach. Can you write out a partial products approach? Let's give you another try on the next screen. Go ahead and copy down the problem. And I gave you some hints here as well, where you will write out 3 numbers and then remember what to do with those 3 numbers. Pause that video while you do your work. What did you write on that first line? Hopefully 15, because that's 15 ones. Next should be 3 tens, which would be worth 30. And then finally on the last line, that's 6 hundreds, which is worth 600. Make sure to put the plus sign there because you are adding those partial products to get the product of those numbers, or the answer to a multiplication problem. In the ones place, that's 5. In the tens place, 4, and a 6. So that 215 times 3 does give you 645. Here's a check using a standard algorithm. 3 times 5 does give you 15. 5, regroup a 1. 3 times 1 is 3, plus 1 is 4, and 3 times 2 is 6. So this right here, standard algorithm, and you had worked out partial products. They will give you that same answer. And they are, of course, connected. That 3 times 5 was that 15. The 3 times this 110 was 30, and I added in 1 because 5 ones times 3 was 15. Not just in 15 ones, where I regrouped 10 of those ones into the tens place. And of course, I had 2 hundreds times 3, which was right there. Let's show you one more, where it is that we're going to solve 4 times 2,376 using a standard algorithm. First, I have to set my problem up correctly. I should be thinking about 2,376 ones, and then multiplying it by 4. what place do I start in? Do I start with the 2, the 3, the 7, or the 6? Right, I start with the 6, and what am I multiplying by? Well, it looks like 4. Multiply that by 4. 6 times 4 gives you 24. What do I place in the ones place? A 4. And what do I place in the tens as a regroup? A 2. There was my 2 tens with that 4 ones. Next, 4 times 7 is 28, plus 2 is 30. So I'll place a 0 in the tens place, and a 3 over this 3 here, which is my regroup for the hundreds. 4 times 3, hundreds, is 12 hundreds, plus 3 is 15. Do make sure to add in those regroups when you're working through that standard algorithm. Again, that was 4 times 3 is 12, plus 3 is 15, so I place a 5 and regroup a 1. You'll notice that my digits are nicely lined up, and one of the common mistakes is to not add in those regroups when you're supposed to. Finally, it's 4 times 2, or 4 times 2,000, is 8 thousandths, plus 1 is 9 thousandths, which I can record right there because I am in the thousands place. So my answer for 4 times 2,376 does equal 9504, which is read how? As 9,504. You'll notice I did get a 4-digit answer here, and I was multiplying 4 digits by 1 digit. We can also get a 5-digit number. Now, if you got a 3-digit answer as your product, you probably made an error somewhere.